Okay. So, you can say mapper is a function which process the input data. So, you have seen this mapper function in word count problem also, an average of the number in this function you have seen. So, just we are getting into the more detail about the mapper function, or you can say the mapper is actually it process your data, okay, it process your data, and what it do, it creates several chunk of data. So, that means if when I say word count problem, it is actually taking one word and it is mapping with one integer 1, and then it is creating a lot of chunk of data into that. So, now what happens, like you can say that input to the mapper function, now input to the mapper function is your key and value pair. So, this is important, and then this value pair is the mapper is getting from the input splits, and input split actually it is record writer record reader is actually creating your key value pair for you guys. Or you can say that it may, or you can say it may use or completely ignore the input key, right. Example, in the word count problem you have seen that mapper function has completely ignored the input key. Let's say let's get into the detail how that it happens, right. Now, you can say that actually mappers read one line at a time, right. It read one line at a time, we have seen in the program also, and then just I will use a different color in that, and you can say that this actually the key which we have seen in the word count problem is key is the byte offset of the file where the input was stored, the byte offset of the file at which you can say line actual starts, right. So, this was the byte offset, and then in our program of word count we actually ignore that. So, you can ignore that also, it depends upon the processes and it depends upon the scenario where you need to that. And you can say that actually in that scenario what was the value? The value was actually the content of the line, the content of the line was the value, and that we actually process this value, right. So, what we did in word count problem, we string tokenize, or we can say we segregated with the regular expression each and every word, right. Each and every word it processed, and it chunked each line into the each and every word, and it processed each and every word, right. And in that scenario you could say that key is considered irrelevant, right. And let us say if you are saying that if the mapper write, you can say anything as an output, the output will be, the output must be in the form of, again in the form of key value pair. So, that is important because in MapReduce key value pair is very important, right. So, now let us see some of the functions, some of the mapper functions, like what kind of mapper function can be there in this, right. So, let us understand the some of the mapper function. So, let us take an example, let us say first one I am taking as an like a upper, and these functions are very simple. There is nothing new in that, just I am just giving you the different nomenclature. Let us say you can say upper function, uppercase. So, in that what will happen, that then the mapper will be something like that, key value pair, this is a map, and actually internally this is using the emit function, okay. So, emit like k dot, you will say k dot key dot key, what is a k? K is a key, or you can say you can write like this to upper, or even for value also you can write to upper, okay. This kind of uppercase function. Now, what this emit do is, emit is actually converting the emit this emit is actually emit will convert into strings. That means it is actually emitting the value of tuple as a tuple key value pair. So, it is converting into string, you can say it is internally using some built-in string str function, some kind of function it is using, and actually this emit is producing the key value pair. So, it is doing something, it is just producing a key value pair, and internally the map function will use the emit function. That means, emit function will be a very common function internally, and it is going to just to release a key value pair of tuple kind of like. So, this is a simple upper function, and if we see some more function in mapper, let us say there is another function kind, something like an explode. How we can do that? So, let us say we have a map function like key value pair, and this function will work something like that for each, or rather I should say in the bit one. So, I will use this one. Let us say for each, and this is a very function like small function character C in V. So, that means all the value from the V will go one by one to this, and then it means like you are saying that now you can emit, now you can say V emit, and then you are saying key comma C. That means the value will be here, and for each means it one by one it will go to C, and then it will explode like the same key will be there, but there will be so many values will be there. So, it will be something like it will generate a explode value. So, this is a very common function in Python, right. So, if we see some more function like filter is very common function which is very simple. So, now I am using map, again key value pair, okay, and if I say if I am using some general function called is prime, and I am saying if my value is prime, then in that scenario I can say that okay, that is emit key value pair. So, it is just it will release this value of key value pair when the value of the V is actually a prime value, okay. Okay, no problem. So, explode in the sense, let us say let's understand this way explode. So, let us say there is a one key called, let us say A is a key, and the value is in there 1 by comma 2 comma 3, these are the values. So, now when we write an explode, what will happen? It will become 1 K1 A1, and then A, and it will become A comma 2, okay, A comma 3 and A comma 4. So, that means this is an explode, right. So, this is actually an explode. So, A comma 3 and A comma 4, that means this is a tuple, and tuple the value are in the list. So, now what it will do, it will take all the V's, V contain 1 2 3 4, and it will contain 1 by 1, C will contain 1, and then it will say tuple, emit tuple, okay, and then similarly for the next iteration it will, for each means it will iterate for each value. Is that okay, guy? This is very simple one, okay. So, you have done in Python also. So, now if we see some more function like you are changing the key space, these are the function from Python you have done in lambda. So, I am doing nothing new thing, but I am just correlating those things with from the MapReduce perspective. So, let us say we have a k value, and this is your changing key space. So, changing key space something like that, you are changing something like v dot length you are putting over here first, and then you are saying this is a function, and then you are putting v. So, that means just you are iterating this thing over here. Or changing key space can also be like that, you are emitting and you are saying okay, let us put the value first and the key sometime. So, we can also use this function when you will do the Spark. So, you will do the Spark, then we will also use these kind of transformation. So, this is also one of the transformation. So, you can do anything with that, and this is you have done in lambda. In lambda function in Python, okay. So, this is something same. So, again the next one, if I say identity mapper, if I say, so what is an identity mapper? So, it is something like map and then key value pair, and then it says that simple emit and key value, that means this is an identity mapper, right. So, in this map function we will do this thing. So, this is simple mapper. So, guys, any question in this one? So, otherwise we can move to the reducer part. So, now what is a reducer? So, now let us see what is a reducer. So, you can say reducer is again is a process, reducer process output, you can say it process the output, reducer process the output of the mapper, okay, mapper function. Or you can say what happens after processing, the reducer produces a new set of output, and what it do, it takes actually it takes intermediate key value pair as input, and what it does, it runs the reduce function. If you remember, there is a reduce function we are going to do in this detail. So it runs a reduce function. So it runs a reduce function on each of them, right. So what kind of reduce function, like let's say you can say example aggregate, we have done it aggregate, or it can do some statistical function, or you can say that it can combine the data also. So it can combine the data, right. Now you can say that whenever the reducer runs, the reducer actually runs in parallel as independent, right. So now you can say that user, now it depends upon the user decided the number of reducer. So let us say users can decide the number of reducers, and default in our case is actually a 1. Okay. Now how we can increase the number of reducer? So you have seen the job function, job class. In job class we have a set num reduce task. Okay, just I need to check R is capital or small, but I think R is small. Okay, so I just need to check. So now integer you are set the number of reducer, right. You can do that in that way, you can increase and decrease, but default setting is 1. Now what happened, HDFS actually stores the output data from reducer. So this is the basic functionality about the reducer. Now I will tell you, whenever you run a program, you have seen two things, one is a mapper and a reducer, right. So there are two things in the whole processes, but what happens when we consider all the different staging also, like shuffle and sort, as a complete reducer part, right. So now we can say that there are three different phases which we can consider as a shuffle, sort and reduce. So you can say reducer is actually combining these stuff because internally they are doing the things parallelly, but when you run the program you are only using the word mapper and another word is the reducer. So shuffle and sorting you are not doing anything because it comes under the functionality of reducer, because whenever things are needed you will take the data from the reducer only. So just to understand that in a better, let's understand what are the three different phases. So let's say three different phases we should know. So out of three different phases, one is your shuffle, right. So now let's put more focus on shuffle, sorting and reduce functions, right. So then it will give you a more clearer idea, and then later we will see some of the functions of the reducer. So now what happens in reducer, in shuffle, you can say shuffle actually transferring data from your mapper to reducer, right. So shuffling is actually transferring data from mapper to reducer, or say mappers to reducers, right. And then what happened, reducer actually copies the sorted output from you can say from each of your mapper, from each mapper, and it using like some kind of HTTP, because it's a network, and you can say HTTP across the network, right. So this is across the network, so it uses some kind of HTTP just to transfer the data from each mapper. Okay. So reducer is going to copy the sorted data, so sorted will be there, right. So now third, you can say that your shuffling actually can start, the shuffling process can start like even before your mapper phase completes, even before your mapper phase or mapper functionality has finished, because just to save some time on that. So it can start once the mapper is producing output, it can transfer the data from the mapper to reducer, so that it can save time. It will not wait till the end of the mapper function. So this is about the shuffling phase. So second one is your sorting. So second is your sort. So when I say sort, I mean to say that this phase covers your merging and you can say sorting both of your map output, right. So this is very important. This phase cover your merging as well as sorting of the map output, right. So merging and sorting of the output. So now what happens, the data from the mapper, your map function, the data from your mapper or map function are actually grouped by key. So why group by key is needed? Okay, so group by key, and then what happen, it splits among reducer. Okay, this is very important functionality of these map reduce function, and then it sorts by key. So these are the functionality what the mapper do. So group by key, something like, so let's say you have a department, and in department you have n number of employees are there. So what you will do, you will group by key, that means you will take a department 1 and you will group together all the stuffs. So here in the word count problem, let's say I have one word called reduce, then I will just do the group by key. Okay, then what I will do, I will group by key and I will make them in a sorted order, and then first I will take all the words which are all the number of words where the map, or let's say map function, map word is there. So I will all group all the maps together from across the text and which are there in the producer in the map function, and then I will first group them by group by key, and then after that I will sort according to the data. So sorting will also be then, and then I will sort by key, right. So if you remember, there are, let's say 5 words are there, let's say fox is there, dog is there, cat is there. So first I will group the data with the help of group by key, where all the cats will come together, and then after that all the data will be in a group by manner, and then I will do the sorting. So sorting will do the sorting, that will help us into this. So sorting will be there. So it means that you can say every reducer obtain or get your all the values, right, all the values associated with the same key, with the same key. So if you remember, I told you that the key, one reducer will get all the values of the particular same key, and it will not distribute to some other reducer. So this is very important point. If you remember, I told you on this last session also. And you can say it does not sort values passed to each reducer. So in reducer side, it will not do any kind of sorting, right. So it will sort before that, it is the intermediate step. So now very important point to remember about this is that, this is, you can say, put as a note that your shuffling and sorting in your map reduce is not performed at all. This shuffling and sorting in the map reduce will not perform at all, like if you specify that 0 reducer. So if there is no reducer, then shuffling and sorting will not be there. And how you can do that? You can set num reduce task equals to 0, and then in this scenario you can done this part. Okay, I think it should be capital because this is a new nomenclature. So I think it's a capital one, right. So if you set the number of reducer's task is 0, then the sorting and phases will not be there. That is why I am saying that this sorting and shuffling is also part of the reduce function, if I say on a very high level, right. So now last point left is reduce. So if you have any problem in this shuffling and in this slide, so please ask, and then otherwise we will move forward. So let's see the third step. The third step is your reduce. You can say reduce. The third step is reduce. Okay. So I'm using the function called reduce. That means when I say reduce, I mean to say that I am talking about the reduce function. So this is a part of the reducer, whole big picture of part. So this reduce method is called on each key, right. So the reduce function is called in each key in the input, right. So whatever the input you provided, it will be called on each and every one. Similarly, you can say output of the reduce task is written to the record writer. So, if you remember we have done this also, record writer. So, this will be passed to this, or now you can say that the output of the reducer is not resorted, because the output we get is like cat 3 bat 4 times. So, this is not a sorted resorted. So, this is there in the reduce part. Now, just to see some of the functionality, some of the functions of the reducer, like let us say first you can say sum reducer, let us say the first is a sum reducer. So, you are summing it up. So, you can call like this is like some reduce, and you are saying key comma value, okay, and then here you have initialized some sum is equal to 0, because we need to calculate the sum. Now, you are calling for each function. So, you are saying that for each int I, and like in your value, because there are a lot of value are there, right, for each, then I from the value I will be one value will be there, and you are calling sum plus equals to, this is your shortcut operator, and equal to sum plus I is equal to equal, and then and eventually you are, once everything is done, then after this for loop you are emitting the key and the sum. So, this means this is actually internally sum reducer will work. So, I think this is simple programming. I do not think there is any big problem into that. Okay. So, in case you have, please ping me and unmute yourself and ask. So, let us see another function. So, another function is called, let us say average reducer. So, average reducer, I can say that, let us say we have a reduce function is like k value, k comma value, and then here we have a sum is equal to 0, or we are also initializing some counter variable countr is equal to 0 variable. So, how it works? So, it is saying for each, I am saying int I am using as a temporary variable for getting the value from the int value, okay, val or value, let me write value, right. And in this what I need to do is I need to use sum is equal to plus, and then I am calculating the sum, the same program you have done today in the lab, and similarly now you have to counter is equal to 1. So, that means I am here increasing the counter, right, increasing the counter, and here we are making a total of sum, right, we are taking total of sum. Now, once this for loop is done, then you can write emit, and then here comma, and I need to get the average sum upon, and you can say counter, and this is the same program what we have done in the lab 3. Okay. Now, you can also take let us say if I say identity mapper, identity reducer. So, identity reducer is something like similar one. So, this is not a big problem, you can say reduce function k comma value, okay, and then you can say for each you are taking, so let us say v in some value function, and then you are saying emit k comma v. So, this is very simple calculative function, right. So, now this is about the mapper and the reducer a little in detail, including some of the functionality. So, guys, do you have any question, or like we can move to the, because one more topic we can cover. So, I just want to see the combiner also. So, we have around 25 minutes left. So, I just want to cover some of the part of the combiner if you are able to complete it. So, guys, any question on to in this topic? So, now let